So, hello student. In the last class, we have discussed about the rank of matrix, transpose of matrix, types of matrices, and to find the inverse of matrices and determinant of matrices. Now, in this video, we will solve some other question and other topic. If some remain, okay. Just a minute. Wait a minute. Now, the properties of determinants are properties of determinants. Similar. Multiply number with their respective cofactor by either row or either column. Property of determinants. First property is transparent of A. Second property is if suppose this was the determinant A is equal to 261 minus 305 and 54 minus 7. Now, if I change any row by column, R2 change to R3, then minus sign will come outside the determinant. If any row or any column can be changed, so 2, 1, minus 3, minus 3, 5, 5, minus 7, 6, 0, 4, then minus sign will come outside. So what is this property? If any two rows or column of a determinant changes, of a determinant for determinant interchanged, the sign of determinant changes. The sign of determinant changes. Now next property is third property. If all element of a row or a column, if all element of a row or column is 0, then the value of determinant will be 0. Then the value of determinant is 0. Means if in either row or a column, if all the elements of a row or a column became 0, then the value of determinant became 0. Suppose A will be the determinant in which the element are 0, 0, 0, 3, 4, 5, 1 to 1. So in this all the element of a row is 0, so the value of determinant A is 0. Now take the element determinant B, in which the element 0, 0, 0, 1, 2, 3, 4, 5, 6. Now in that case also the value of determinant became 0. Now fourth property, if any two row or column of a determinant of a determinant are identical, then the value of determinant is 0. Then the value of determinant is 0. That means suppose A will be the determinant in which element are 1, 2, minus 1, 5, 0, 7, and 1, 2, minus 1. In that case, column 1 and column 3 are equal. So the value of determinant is 0. And in B, 215, 215, 0, 1, 0. In that case, R1 and R3 are equal. So the value of determinant B equal to 0. Means and any two rows or any two column are equal, then the value of determinant is 0. Now next is fifth one. If each element of a row or a column of a determinant is multiplied by a constant k, is multiplied by a constant k, then the determinant's value, then the determinant's value get multiplied by k, get multiplied by k. Now what is this? Suppose the value of determinant is 1, 2, minus 1, 0, 5, 6, and 1, 0, 2. Now if you multiply any row or column by k, now multiplying row 1, so k1, k2, and k into minus 1. So the value of determinant get multiplied by k. Now if you multiply second row by k, then k. So you will get k square. Now if you multiply by third row by k, so you will get k cube. So generally one more property is from A come that if you multiply k by a, then it is always equal to k to the power of n dot a, where n is order of k, where n is order of k, where is n is order of k. Now if you seen in that part, if you multiply k by a, which means that all the elements multiply by k, so that condition means that condition come. So so here outside the k to the power n will come. What is the k to the power n? N is number of sorry, order of a, and the order of a is 3 by 3. Okay, that's why this was very important property for your exam point of view, that if all the are multiplied by constant k, so the value of k to the power n, where n is the order of determinant and mod a, mod is determinant of a. Now second one is sixth property. If elements of a row or a column, if elements of a row or column of determinant are expressed as a are expressed as a sum of two or more terms, then the determinant can be expressed as sum of two or more terms, as sum of two or more terms or more determinants. Now suppose this was your determinant a plus 2x upon x, b b plus 2y y, c plus 2z or yeah. So you can return it by two determinant a x, b c z, and plus a 2x b 2y c 2z z. Okay. So what this property can say, what this property is saying, that a determinant can be expressed as a sum of two or more terms. Okay, if all the rows and all the element of for row or any column can be expressed as the sum of two. Okay. Now next property is property number 7. If in a determinant, if in a determinant all elements above or below the diagonal or below the diagonal are 0, then value of determinant is a product of diagonal elements. If the determinant is like that, a 0 0 0 b 0 0 0 c, I mean only element present in the diagonal, rest all the element are 0, then the value of determinant will be a into b into c. This will multiply all the elements of the diagonal. So a b c will be the value of that determinant. Okay. Now there are two type of a matrix: singular matrix and non-singular matrix. So what are singular matrix and what is non-singular matrix? So singular matrix is a matrix whose determinant is 0. A square matrix, a square matrix with a determinant is 0, with a determinant is 0, is called Singular matrix. That means mod A equal to 0. Non-singular matrix in which the value of determinant is not 0. That are non-singular matrix. Non-singular matrix. Simply you can write like whose determinant is not 0 is known as non-singular matrix, and whose determinant equal to 0 is known as singular matrix. Now, next is orthogonal matrix. Orthogonal matrix. So orthogonal matrix is a matrix which follows the condition that if you multiply a matrix with its transpose, if you multiply a transpose of any matrix with its type, so you will get an identity matrix. So that was the condition of orthogonal matrix. Now I am discussing some question which was come in your previous year. Now the question is which come in year 2000. And a long answer type question, and it is of uh, 2019. The question is show that determinant of A, B, C or B, C, A and C, A, B is equal to A time A cube plus B cube plus C cube minus 3ABC whole square plus, sorry, is equal to 2BC minus A square C square B square C square B square 2AC minus B square 2AB minus C square A square A square. Now how we can solve? Here is a square. Huh? So generally what is the value of A B C B C A C A B? A, B, C, B, C, A, C, A, B. Now the value of A, B, C, B, C, A, C, A, B is A, C, A, A, B minus B, B, C, A, B plus C, B, C, C, A. Now you multiply, you will get A, C, B minus A square minus B, B square minus AC plus C, AB minus C square. Now if you multiply, you will get ABC minus A cube minus B cube minus, sorry, plus ABC plus C cube and, sorry, plus ABC minus C cube plus ABC minus C cube. So you will get minus of A cube plus B cube plus C cube and ABC minus 3ABC, because I have taken minus common. So this will become positive and 3ABC will become negative. Now this is the value of ABC, BCA and CAB. Now what is the value of ABC, BCA, CAB whole square? Whole square means minus minus will become positive. So A cube plus B cube plus C cube minus 3ABC whole square will be its value, and we have proved that part. Now for the second part, ABC, ABC, BCA, BCA, CAB, CAB whole square can be written as ABC, BCA, CAB into ABC, BCA and CAB. Now transform in this matrix R3 to R2 and R2 to R3. So you will get ABC, BCA, CAB minus 1 of ABC, CAB and BCA. They are in multiplying. Now I'm multiplying minus 1 inside of row 1. So if I multiply minus 1 inside this row O, so here will be minus 1 whole square, because minus 1 is there, and now I am multiplying with minus 1. Now A, B, C, B, C, A, C, A, B. Now I'm multiplying minus 1 here, and in a matrix, I am multiplying here with row 1. So A minus B minus C, C A B, B C A. Now minus 1 is equal to plus 1. So the value will become A, B, C, B, C, A and C, A, B into minus A, minus B, minus C, C, A, B and B, C, A. Now multiply these matrices. So you will get first row multiply with first column. So minus A square plus BC and plus CB. Now first row multiply by second column minus A, just minus A minus AB plus AB plus C square. Now multiply first row with third column. So minus AC plus B square plus AC. Now multiply second row with first column. So minus AB plus C square plus AB. Multiply second row with second column. So minus B square plus AC plus CA. Multiply second row with third column minus BC plus CB plus A square. Now multiply third row with first column. So minus AC plus AC plus B square multiplies third row with second column minus CB plus A square plus BC. Now multiplies third row with third column. So minus C square plus AB plus BA. Now minus AB will cancel, minus AC will cancel, minus AB will cancel, minus AC will cancel, and minus BC will cancel, minus BC will be cancelled, and plus sorry plus AB is not cancelling. So in first we will get 2BC minus A square. So in the first we will get 2BC minus A square, C square, B square, C square, B square, C square, B square. Now here 2AC minus B square, 2AC minus B square, A square, here A square and 2AB minus C square, A square and 2AB minus C square. So that was equal to your RHS. That one. This was very important question. It was repeated 2 times in your examinations. One is your one more topic is left. That was your Cramer's rule. Cramer's rule. Now, firstly, I am writing it ax plus by plus cz equal to you can take any value. Suppose you can take u px plus qy plus rz equal to v and mx plus ny plus oz is equal to w. Now make the determinant of that one. So that was your determinant. What is the value of determinant? That was the coefficient of all A, B, C. That means A, B, C, P, Q, R, M, N, O. M, N, O. So the determinant is the determinant of coefficient of x, y, z is denoted by delta. Now, what is delta 1? Delta 1 means that one is taken at position C1. So U, V, W, rest all are at the same position. P, Q, N, and C, R, O will be the value of delta 1. Now, what is the value of delta 2? Means that one is taken as at column 2. So A, P, M U V W C R O will be the value of delta 2. Now the value of delta 3. Delta 3 is that one is put at third column. So U V W A B P Q M N. So that was the value of delta 3. Now the value of X is delta 1 upon delta. The value of Y is delta 2 upon delta, and the value of C will be delta 3 upon delta. So that was Cramer's rule. Cramer's rule tells us that if equation is come in the form that ax plus by plus cz equal to u and px plus qy rz equal to v and mx plus ny plus oz equal to w. So you can find data, that means determinant of a b c, the coefficient of x y z, means LHS coefficient, the coefficient of all terms in LHS, they are determinant. And now delta 1 is put the RHS value in first column, and delta 2 means put the RHS value in the second column. Rest all the elements are same. And delta 3 means put this value in the third column, and rest all the values are same. Now next is I am solving a question based on this. Question is x plus y plus 3z, x plus y plus 3z equal to 5, comma 4x plus 2y minus z equal to 0, comma minus x plus 3y plus z equal to 5. Solve the system of equation by using Cramer's rule. Solve the system of equation by Cramer's rule. The first step is write all the equation. So x plus y plus 3z, x plus y plus 3z equal to 5, 4x plus 2y minus z equal to 0, minus x plus 3y plus z equal to 5. Now firstly take the determinant. So determinant equal to 1, 1, 3. All the coefficients of x, y, z. So 4, 2, minus 1. So minus 1, 3, 1. Now find the value of determinant. 1 into 2 minus 1, 3, 1. Minus 1 into 4 minus 1, minus 1, 1. Plus 3 is equal to 4, 2, minus 1, 3. So you will get 1, 2 minus minus of 3, 2 plus 3, minus 1, 4 minus of minus 1 plus 1, plus 3, 4 3 is 12, plus 2. So 1 is equal to 1, 2 plus 3 is 5, 4 minus 1 is 3, so minus 3 plus 3, 14 3 is 40. Just a minute. 12 plus 2 is 14. Yes, 14 3 is 42. So the value will become 5 plus 3 plus 42. Minus will become plus. So you will get value 50. Now the value of delta 1. The delta is equal to 50. Value of delta 1. Delta 1 means to put all the value of RHS in the first column. So 505, 505. And second column is 1, 2, 3. And third column is 3 minus 1, 1. 1, 2, 3, 3 minus 1, 1. Now solve for delta 1. So 5 2 minus 1 3 1 minus 1 0 5 minus 1 1 plus 3 0 2 5 3. Now multiply them. So 5 2 plus 3 minus 1 0 into 1 is 0 minus 5 will become plus 5 plus 3 5 to 10 minus 10. So 2 plus 3 is 5 5 5 just 25 minus 5 minus 30 minus 5 3 minus 10 is 30. Just a minute. 13513. So the value will become minus 10. Now solve for delta 2. Delta 2 is put this value, RHS value, and second one. So first column is 1 4 minus 1, third column is 3 minus 1 1. So 1 4 minus 1 1 4 minus 1 3 1 1, sorry, 3 minus 1 1 and 5 0 5. Now solve for delta 2. 1 0 5 minus 1 1 minus 5 4 minus 1 minus 1 1 plus 3 4 0 minus 1 5. Now multiply them. So 1 0 into 1 is 0 minus minus 5 will become plus 5. So minus 5 4 into 1 is 4 and minus 1 became plus 1. So minus 1 plus 3 4 5 is 20 minus 0. So 1 plus 5 is 5 minus 4 minus 1 is 3. So minus 15 plus 60. So 65 minus 50 will become, just a minute, I'm checking the calculation. So 65 minus 15 will become 50. Now delta third. Delta third will be put this value in the third column. First column is 1 4 minus 1. Second column is 1 2 3. 1 4 minus 1 1 2 3 and 5 0 5. Just a minute. I have to check whether I am writing correct or not. 1 4 minus 1 1 2 3 5 0 5. 1 4 minus 1 1 2 3 505. Now solve for delta 3. So you will get 1 2 0 3 5 minus 1 4 minus 1 0 5 plus 5 4 2 minus 1 3. So you will get 1 2 5 just 10 minus 0 minus 1 4 5 just 20 minus 0 plus 5 4 3 just 12 plus 2. So 10 minus 20 plus 14 5 just. Okay. Now 70 80 minus 20 60 will be the value plus 2. Okay, now the value of delta 1 x is delta 1 by delta. The value of y is delta 2 by delta. The value of z is delta 3 by delta. So delta value is 50 and delta 3 is 60. So you will get 1.2 and the value of y is delta 2 is 50. So 50 upon 50 is 1. 50 upon 50 will be 1. Now the value of delta 1 is minus 10 upon 5. So you will get minus 0.2. So that was the value of x, y, and z. This question is so that determinant of a minus b minus c 2a 2b 2b 2c b minus c minus a 2b 2c c minus a minus b is equal to a plus b plus c whole cube. Now the solution of that one is I'm taking LHS, taking just a minute, Ashton. So question is taking LHS, taking LHS, which is equal to A minus B minus C, 2B, 2C, 2A, B minus C minus A, 2C, 2A, 2B, C minus A minus B. Now I'm transforming R1 to R1 plus R2 plus R3. Now A minus B plus 2b, which will become plus b, and minus c plus 2c will be, which will become plus c. Similarly, in the second row, you will get the same. In the first row, you will get the same a plus b plus c, and in third row, you will get the same a plus b plus c. So on applying this transformation, you will get a plus b plus c, a plus b plus c, a plus b plus c, 2b, 2c, b minus c minus a, 2c, 2b, c minus a minus b. Now taking a plus b plus c common, so I will get, if I take a plus b plus c common from row 1, so the value will become 1 upon 2b, 2c, 1 upon b minus c minus a, 2c, 1 upon 2b, and c minus a minus b. Now transform C2 tends to C2 minus C1, C2 minus C1, and C3 tends to C3 minus C1, C3 tends to C3 minus C1. So you will get A plus B plus C 1 upon 2B 2C. 1 minus 1 will become 0. B minus C minus A minus of 2B. So you will get minus B minus C minus A, minus B minus C minus A, and 2C minus 2C will become 0, and 0, 2B minus 2B will become 0, and C minus A minus B minus 2C will be minus C minus B minus A. Now if you multiply open by determinant R1, So you will get a plus b plus c into minus minus of minus 1 whole square, a plus b plus c whole square. So you will get a plus b plus c whole cube as the value of that determinant. Now the next question is show that show that a plus b plus 2c, a b c c, b plus c plus 2a, a b c plus a plus 2b is equal to 2 times of a plus b plus c whole cube. So firstly I am taking LHS. So the value of LHS is a plus b plus 2c, a b c c, b plus c plus 2a, a b c1 tends to c1 plus c2 plus c3. Now if you see here, so you will get a 2a, 2b, 2c. Similarly in the second one, c plus c will become 2c and b plus b will become 2b and 2a. In the third one, c plus c will become 2c, a plus a will become 2a and 2b will be there. So you will get 2a plus 2b plus 2c. Here also 2a plus 2b plus 2c, 2a plus 2b plus 2c, and a b plus c plus 2a, a b b c plus a plus 2b. Now taking 2a plus 2b plus 2c common from row 1, sorry, column 1. So you will get 2a plus 2b plus 2c common. After taking common, 1 1 1, a b plus c plus 2a and a b b c plus a plus 2b. So now R2 tends to R2 minus R1 and R3 tends to R3 minus R1. So on solving, you will get 2a plus 2b plus 2c, 1ab. Now subtract R2 from R1. So 1 minus 1 will become 0. B plus c, 2a minus a will become a, b minus b will become 0, 1 minus 1 will become 0, a minus a will become 0, c plus a plus 2b minus b will become a plus b plus c. Now open by column 1, so you will get 2a, 2 common from here, a plus b plus c. Now multiply with there, so you will get a plus b plus c whole square. So 2 into a plus b plus c whole cube will be your answer. So student, that's all our for your, that's all our important question for you. So now in the question is left. Now one more question is left. Question is, if a equal to -1201, find a dash. Firstly, I'm finding a transpose. A transpose is transpose of that matrix. So -1021. Now a into a transpose will become -1021 into a into a transpose. Now firstly I'm writing a is -1201 and -1201. Now you will get 2 by 2 matrix, multiply first row with first column. So you will get -1 into 1, 1 plus 4, -1 into 0 is 0, 2 into 1 is 2, 0 into -1 is 0, 1 into 2 is 2, 0 into 0 is 0, 1 into 1 is 1. So you will get 5221 will be the answer. Now next question is, now solution is, so that one 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 a b c a square b square c square a square b square c square is equal to a minus b minus c minus a. See the solution. LHS taking one one a b a square b square c square. Now R2 tends to R2 minus R1 and R tends to R3 minus R1. So you will get 1 a square minus 0, so b minus a, b square minus a square, and 0, c minus a, c square minus a square. Taking minus a, c minus a common from R and R3. Taking minus a common from R2 and R3. So you will minus c 1 0 0 a 1 1 a square b plus a and c plus a. Now expand c1, so you will get b minus a zero a minus b minus c. So you will get c minus b. So the value will become b minus a, c minus a, and b minus, sorry, c minus b. Taking common minus a, so a minus b, b minus c here, and c minus a equal to s. I have taken minus common, minus common from this minus 1 will become 1. Now the next question is, next question is, solve the following following system of equation by using Cramer's rule. System of equation by Cramer's rule. By Cramer's rule. So what is the system of equation? 2x minus 3y, sorry, 2x minus y plus 3z, y plus 3z equal to 9. Second one is x plus y plus z equal to 6. Third one is x minus y plus z equal to 2. Now solve this by same method. So first is delta 1. Say I'm writing the equation. The equations are 2x minus y plus 3z equal to 9. Second one is x plus y plus z equal to 6. Fourth one is x minus y plus z equal to 2. Now the value of delta will be coefficient of all the term 2, 1, 1, minus 1, 1, minus 1, 3, 1, 1. Okay, so the value of delta will be 2 times of 1 minus 1, 1 into 1, minus 1 will become plus 1, 1, 1, 1, 1, plus 3, 1, 1, 1, minus 1. So you will get 2, 1, plus 1, plus 1, 1 minus 1, plus 3, minus 1, minus 1. So 2 into 1 plus 1 will become 4, plus 0, minus 3 minus 2 will become minus 6. So you will get minus 2 will be the value of delta. Now delta 1. delta 1 will be the value of RHS value 962 take in column C1. So delta 1 equal to 962 minus 1 1 1 3 1 1. So the value of delta 2 will become delta 1 will become 9 of 1 1 1 1 minus minus will become plus 1 6 2 1 1 plus 3 6 1 2 1. So value will become 9 1 minus 1 plus 1 6 minus 2 plus 3 6 minus 2. So 9 will become 0, 6 minus 2 is 4 plus 3 4 ja 12. So you will get value 16. Now delta 2 is put the value of 962 in delta second column. So 2 1 1 962 3 1 1. So delta 2 equal to 2 times of 6 2 1 1 minus 9 of 1 1 1 1 plus 3 of 1 6 1 2. So 2 is 6 minus 2 minus 9 1 minus 1 plus 3 2 minus 6. So 2 4 ja 8 minus 3 4 ja 12. So minus 4 will be the answer of delta 2. Now next is delta 3. Delta 3 is put 962 in first part in third column. So you will get 211 211 minus 1 1 minus 1 minus 1 962. So you will get 2 1 minus 1 6 2 minus minus will become plus 1 1 1 6 2 and plus 9 1 1 1 minus 1. So you will get 2 the 2 plus 6 plus 1 2 minus 6 plus 9 minus 1 minus 1. So 2 into 2 6 yeah, 8 2 6 8. So 2 is 16 minus 4 minus 18. So you will get minus 6 as the value of delta 3. Now the value of x is delta 1 by delta. The value of y is delta 2 by delta. The value of z is delta 3 by delta. So delta is minus 2 and delta 1 is 16. 16 upon minus 2. So you will get minus 8 as answer. Delta 2 is minus 4 upon minus 2. Minus 4 upon minus 2. So you will get 2 as answer. Delta 3 is minus 6 by minus 2. So you will get 3 as an answer. So minus 8 to 3 will be the value of x, y and z. So student, that are some important question of matrices which has come in your previous year. I have covered all the parts and all the concept from that. If you have any doubt, then you can send to madam or you can comment in the comment box, so I can watch that what topic you want and in which topic you have down, so I can again explain that topic